joining us from gNext today. He brings over 30 years of experience as a software entrepreneur, having built and operated impactful technology companies in both the US and the UK. At gNext, he's focused on delivering top-notch technology and support to the growing infrastructure asset inspection market. With AI now helping eliminate bottlenecks in asset inspections, gNext is leading the way in bringing these cutting-edge solutions to market. So please join me in welcoming Russ Ellis, President of gNext. Hi, Russ. Welcome to the show.
Thank you very much, Vishali. I'm really pleased to be here today and working with some great partners with FlytBase. So I think this is going to be a really impactful seminar or a webinar, and I'm looking forward to it with you.
Joining along with Russ is my colleague Ajinkya, who is going to walk us through the role that FlytBase plays in this ecosystem. So welcome again, Russ and Ajinkya. But before we begin, a quick note for all the audience joining us today. We are recording today's session, so feel free to revisit the highlights at your convenience. We are also streaming this session live on YouTube and LinkedIn. So in case any of your colleagues are unable to join this link, they can do so. We'll also have a Q&A session at the end. So please drop any questions or thoughts you have in the Q&A tab. With that, I'll pass over the podium to Russ.
Great, thank you. So just a little bit about gNext. gNext is a SaaS civil infrastructure management platform, and we combine drone data with computer vision, machine learning, and 3D modeling. And the problem we solve is taking these vast amounts of data and securely transforming them and digitizing them. But the goals are really the same in each instance. It's about optimizing capital spend, it's about informing maintenance operations, and above all, it's about extending the safe service life of the asset. Next slide, please. A little bit about how gNext fits into the ecosystem. An inspector and an operator design a route, or they program it into a dock. That drone is deployed to collect that data, and then the data is uploaded to the gNext platform, where it is analyzed in a cloud-based and processed in a cloud-based environment. Next slide, please. We're able to process and manage data from a variety of different inputs and different sensors. Most prevalent is drone collected, often augmented by handheld inspection images. We're also seeing a great deal of data, and we support data collected by vehicle-mounted sensors as well, like the one you see here. It's a big sensor. It's mounted on a vehicle, and they're able to collect data at highway speeds on bridge decks and highways. We also are able to manage data from video, 360 video and 360 images, where you can upload, stream, edit, and annotate directly on those images as well. Next slide. All right, let's talk about some challenges. Next slide. All right, so the challenges with manual, I think, is a fairly well-known. Even though it is listed as third, safety is always top of mind and the most important. But then you start working through all these others, and it really helps you understand that manual has its place, and there are absolutely use cases. There's only one way to do it manually, or to do it, but from a non-doc perspective, I should say. But doing it manually versus doing it via drone and digitized asset inspection, you can see a huge amount of efficiencies that are gained out of drone inspection. Next slide, please. And doing comparisons of data capture and visualization. Manual, we see a 2 people, 8 hours. We see a breakdown equaling $4,600. With drone collection, it's $250, but these are not necessarily apples to apples, but it is to give you the instance or give you the idea of collecting data by drone is so far superior to being manual and having all the assets deployed that are challenging to the environment and challenging to the individuals that are involved. Next slide.
Right. So yes, thanks a lot, Russ, for walking us through what are the current challenges that are faced in manual inspection. And again, in alignment with the topic of the webinar, how automated drone operations can help us increase efficiency and optimize processes. Let's go first through a few challenges that manual piloting or manual data collection has. So here are a list of few challenges that drone solution providers or enterprises face while data collection. The first one is, of course, travel to distant locations frequently. So a lot of these times, the sites that needed to be inspected or the facilities that needed to be inspected are remotely situated. So there's a parameter or there's an element of travel. The pilot has to travel all the way, which sort of increases the costs, travel cost, accommodation cost for the data collection. And the next is a lot of these places are in suboptimal conditions. So the weather or the conditions are not very good for the human to perform activities in those area. And the next is, since there's a travel included and the sites are remotely situated, there are delays in uploading the data to the cloud for processing. And when it comes to use cases like security surveillance, it is technically or not really feasible to have regular security patrols if there's a pilot that needs to be sent to that location. And another element that comes into the picture is the enterprises have to continuously train new pilots as they scale their operations or have more sites that those need to be inspected. And how can enterprises overcome these challenges is with drone in the box solution. And let's focus on why and how docking stations or drone docks are added value. So we will focus on these 4 parameters. First is, of course, increased mission frequency. So when you deploy a docking station at the site, you remove the component of sending a pilot to the site on a regular basis. And this way you have more frequent on-demand data collections for better data quality as well as for better planning. And of course, there is a component of enhanced safety. Automated operations like I said, it reduces the need for on-site pilots and it decreases the chances of any accidents. The next is, of course, cost savings. So on-demand operations or on-demand missions can be launched remotely for data collection. And this on-demand ability can also help gather high-quality data, which can help detect or which can help inspect these assets on a regular basis. So what does it take for an enterprise to have an end-to-end data processing pipeline? So we'll take you through the journey. The first step is, of course, determining the use case. So use cases, there can be different. One can be telecom infrastructure inspection or construction project management. It can be storm damage assessment, dam inspection, bridge infrastructure assessment. So there are multiple inspection use cases that are currently be solved using drone dogs. The first step is, of course, to determine the use case that the user is targeting. And moving on to the next step, it's selecting the right drone and dock hardware, which will help the enterprise or the user capture the quality data or the required format of the data for the user. So in this case, there are a wide variety of options that are available in the market. So let's say if the user is using an M300 drone or M30 drone, they have options like Haisha docking stations, which is charging docking station for these drones. Then if you're in the US and you are using an Anzu Raptor, we have a partner docking stations which supports these Anzu drones. It's called the Hextronics Universal, and the Hextronics Atlas, which is again a docking station for the M300, M350 drones, which has the unique capability of swapping batteries. So this also decreases the downtime of the drone operations. And next is, of course, the DJI docks, which are being widely adopted by enterprises for various use cases, which are compatible with the M30 series as well as the DJI M3 TD drones. The next step is, of course, selecting a drone autonomy platform for remote operations. And when it comes to conducting these autonomous drone operations, it's not only about having the right data processing software, the hardware, and the flight control software, but there are multiple pieces of the puzzle that needs to come together to have safer and efficient automated drone operations. So pieces like detect and avoid systems, ADSB, UTM, the right drone payloads, weather reporting system, parachutes, and multiple systems that need to work in sync to have this automated drone operations. And how can this be achieved is with the help of a platform like FlytBase, which acts as a glue in bringing all these pieces of the puzzle together. And then a user has a single platform which they can manage or use to command and control the drones, as well as see the real-time air traffic in order to have efficient and safer drone operations. So moving on to the next slide. So just summarizing the key points that I mentioned earlier, the first step is, of course, the user needs to decide a hardware which will be relevant for their operation. Then there comes the platform, drone autonomy platform, which takes care of the flight automation part, the fleet management part. If the user has multiple docking stations or sites that they want to inspect on a regular basis, you can manage a fleet of those docking stations from a single platform. And then, of course, the aspects like flight safety and data security are taken care by the drone autonomy platform. And with Flinks and our integration with gNext, the user now has the ability to have a completely end-to-end automated data processing pipeline where automation of the data collection process happens via the FlytBase platform, and then the processing or insight generation of the data that is captured will happen through the gNext platform. So this is what an ideal setup for the operations or remote operations center looks like. One is, of course, the admin view or ops view, where the user is able to manage multiple drones and docking stations from their account. Then there's the mission planning part, where the user can create and schedule these missions in advance. There is the data processing platform, that is gNext, which the user can get the insights of the data that has been captured, and the other supporting technologies like air traffic to have better airspace awareness, and the user or the remote operator knows when they should launch the flight. These air traffic integrations with the air traffic systems are necessary. And then there is, of course, the weather data. So the user is aware about the weather of the location where the dock has been deployed or the site of the inspection. So here are a few examples of the ROC setups across the globe from our partners and customers, where they are using it for inspections of different categories, for construction site monitoring, bridge inspection, and so on. So I will first go through a few pre-flight features of the platform. What are the features that are important to have high quality data collection? So the first is, of course, site management. As enterprises like energy companies, utilities start adopting these docking stations, they are going to have multiple deployments in each of their facilities. And that is where the site management feature, where the organization admin can assign the site to members, assign that site to devices, as well as specific missions, in order to have a better organizational structure and manage their drone operations. Then we have the map overlay function, where the users can overlay their existing maps into the FlytBase platform. This way, they are able to accurately plan their missions for inspections, as well as now they have better terrain awareness of their sites to avoid any mishaps or accidents during the drone operations. Next up, we have mission tags. So a lot of these enterprises are using the solution for multiple use cases. And with the mission tags feature, they can categorize the nature of the mission. Is it for inspection? Is it for surveillance or any other use case? And then the mission tags feature can come very handy in these cases. Then, of course, the mission planning, which is critical when collecting the data. So there are multiple different options where you can create a linear mission or a path mission. And then for use cases like inspection or photogrammetry, you can also have a grid mission in place where you can create these grids which we will of course talk in detail of what kind of parameters the users are able to set up while creating grid missions. And then we also have WPML imports from any third-party applications where the mission planning takes place. And to talk a bit about grid mission planning, so the user has the ability to define the route altitude and also define the GSD ground sampling distance for their operations or for their missions, which increases the quality of the data. And then since the user are now aware about their site, they are able to tweak the parameters into the platform while creating those missions. Next is, of course, the ability to control and set image overlap. User can control the front overlap or the site overlap depending on the type of the data or the quality of the data that they want. And moving forward, we also have payload selection. So like we discussed earlier, there can be different drones that are being used by enterprises for their data collection operations. And then the user can select the right payload that comes with those specific drones in order to have much more clearer data quality. So moving forward, so when it comes to use cases like inspection, it is not one-off use case. A lot of companies, enterprises, they need to inspect the data on a regular basis, and then that is where the mission scheduler function comes into action, where the user can preset these missions on a regular basis. So let's say if energy company wants to inspect their asset on every day in the morning, they can pre-schedule these missions in advance, and every day at 9 a.m. the drone will automatically take off, capture all that data or the media for the mission, and then automatically upload it to the processing platform for further insights. Then next we have with this, again, the next feature that is critical for inspection use case is live mission recording. So sometimes the users
drone's heading are recorded when you hit.
Yeah. So sometimes the user do not have the ability to have custom missions, but with live mission recording, the user can do the first manual flight. And as the drone is flying, they can click on the record waypoint button on the FlytBase dashboard, which will capture the location of the drone as well as the angle of the camera at that specific point. And then once this manual mission is completed, it will create a new mission on the user's dashboard, and that mission can be launched anytime when the user wants to inspect that specific path or that specific area. And moving forward about the post-flight features. So what happens once the mission is completed? So of course, one important criteria is how you manage your media that has been captured during that specific mission. So with the gallery, the user is now able to segregate the data based on the mission name, as well as the date of the flight, the site that it was launched for, as well as flight type and device that was used. So user has this flexibility to add these filters in order to get the right data for a specific site. And then by clicking on the export manager, the user can create an export which can be sent to the post-processing platform like gNext for detailed analysis. So here, once the export is created, the user will see this dashboard in the export manager, where once they click on the share button, they now have the ability to send the media files directly to gNext via the gNext link. And once this is completed, let's talk about the data processing platform. So what will happen once the captured data from these automated drone operations is sent to the post-processing platform? And for this, I again invite Russ back to the stage to talk about the processing platform and what are the benefits of automated data processing and analytics. Over to you, Russ.
Thank you, Ajinkya. So now that we're looking at it more in depth and how we're processing or capturing this data and processing it, we'll take a look at the big, broad overview of why are we doing this. You know, it's the reducing the risk, increasing safety, bringing all of your data into one centralized hub where it can be actionable insights as opposed to siloed data spread across broad organizations. the automated workflows, the accelerated assessment, the quantifiable metrics, all of these combine to create really, really good outcomes for asset inspection. Next slide. All right, let's talk about what we do with this data. Now that it's been expertly captured and collected, we're looking at an AI outcome. So we're jumping right to the meat of the matter. We've collected this data. The GSD's been calculated. We're looking at this is a 3D model. We're looking at a web page in the gNext platform. Now we're looking at how this data has been analyzed through AI automatically. So we're kind of starting at the end. We're going to move back to the beginning in future slides or next slides. But anytime there's an AI feature detection, you can just hover over that defect and it'll give you the analytics about it. So it's not just annotating, but it's quantifying each and every one. We have a lot of different types of assets or different types of defects that have been found in this, including patches. Patches sounds like a repair, but it could be hiding and lurking just underneath another defect. Here's vegetation encroachment, and we're seeing a broad range. Now we're moving directly into CAD software. So one of our exports, many of our customers' workflows, they deliver out of CAD. We send it over to CAD with a table, a legend, and also all the quantifiable metrics about each and every defect that was found. You can turn these layers on and off as you will within the CAD software of your choice, because we can work with them all and send data to the one that fits in your workflows. And here we see examples of an operator going through and turning on and off those layers to really understand the current condition of that asset. Next slide, please. All right, we're going to look at another piece. And again, these are concrete or asphalt asset types. And this is another great example potentially of a dock solution. But what we really want to show you is a large concrete structure that has been inspected several times. You can always, we're in the gNext platform, you can always turn on the camera positions to help you understand how data was actually collected. That's really important to inform if issues arise of holes in a model or that sort of thing. And it's always great for training new pilots. We're looking at a timeline feature here. There are two data sets. This is after remediation. This is before. So the ability to go change over time of your assets is really a critical feature, especially as you've made those remediations and those repairs. Trust but verify. You can really understand all of the changes that have occurred in that asset, both good and bad, over time. Now we're looking at our AI viewer, and we're seeing how these different defects show up. And this was the post-remediation. We can see some cracks that are still there that were not deemed necessary to remediate, it appears. And I think now they have the opportunity, the asset owner has the opportunity to monitor those. But again, hovering over any of these defects, it shows you the quantities, the average width and crack length, and all of the different details that are necessary for you to understand current condition. We'll also see how you can see the change over time from the 3D side of it. Here's where all the defects were found. You can see the relationship between spalls and cracks in this shape, in this view, and it's really telling and helps you understand how that asset is performing. The ability to turn on and off each individual defect that was detected. And let's see how it looks over time. We understand what the condition of that was. we're seeing here an example of the ability to add annotations any place on the 3D model or on the individual images. And we'll see some examples of how you can get to the underlying images very quickly in a next video. Looking at the 3D model and seeing how we're communicating with others as the inspection takes place. Another great use case for a dock, we're seeing a substation, electric substation. This is a model that was created in gNext. We're seeing an operator working through this web-based platform. And I'll just say there's no software to download. It's all web-based. By double-clicking anywhere on the model, you can get to the underlying image, which always has the best data and is critical to have access to. We're going to see a quick annotation being made, a measurement being made here. In the lower left of the screen, you can select which image you want to show in the report, the one that conveys the best data and the best message to the readers of that. Next. A different asset type, it's another substation. And we're seeing the really similar results. The ability to be able to go through and truly understand current condition. And the ability, we'll see some analytics being gathered. We'll also be able to see how data was collected. Each one of those red triangles represents an image snapped in space. We'll see a quick analytics being gathered here. Quick measurement. We'll get to an underlying image, and we have tools to help you better understand that data. So if this is a little bit dark, we can lighten that image on the fly. It's important to be able to access your data where you need it. We're seeing your data in a desktop. Next, we'll see it in a tablet. And finally, we'll see it in a mobile phone. Again, no apps, no software to download, all internet connected and browser based. Really important when you're in the field, you need to be able to understand what did this look like last time we inspected it, or what am I looking for now? You can use whatever device you have and you've got it ready to go. Now we'll see a use case for an urban construction setting. Another great use case for a dock, a drone in a box. Now we're going to see the user interacting with the model and getting up closer to the actual area they're interested in reviewing. We see a new feature or a new tab down on the lower left-hand corner of the screen, which is timeline. And we'll see just how easy it is to go back and forwards in time to look to see what did this look like last time we captured data. Yep. And what's it look like? And back and forward. So if you had 20 different data captures, you'd see them all strung out along the bottom of the screen, where you could examine any two instances side by side, just like this. Really important and really valuable in keeping all stakeholders apprised of the current condition of that project. And oftentimes they're remote, so it doesn't matter where they are, they're able to access the gNext cloud-based platform from wherever they are. Now we're going to see that same in the 2D. Okay, we're moving on. Back, forwards. Let's see where we are here. Go ahead and let this one play. Is this the 2D change over time? No, I think we've gone back. Let's continue to the next. Thank you, Jinka. All right, now we're seeing a larger scale construction project management. This is a 6-mile-long construction corridor. This data was provided by Alabama DOT, and they very gracious in allowing us to show the world. They had a very large project. They're going from a 2-lane to a 4-lane road. We're seeing how data was collected in a series of data collections. that we were able to process all as one model. This is and we're going to see the results here. Let's see exactly how long this is. They're going to do a quick measurement to see what the total project is, and nothing's been sped up here. This is all how the platform operates. 38,000 feet, so we're dealing right just under 6 miles of corridor space. Now let's take a look at some different areas of this. Always could get to the individual images by clicking on the 3D model. It'll show you the best image that's looking at that spot. Now we're going to go back over and take a look at the actual 3D model and look at some of the areas in this corridor to understand what else do I need to look at more in depth. You'll find some things that catch the eye. Oh, that's one that's certainly of interest. We can get rid of that image to the right in just a minute, but first we're going to take a quick calculation of that stockpile. This is a rock, a big boulder that needs to be removed. How much material do we need to replace or haul out of there? So you really understand the analytics on the fly of what needs to be done. So from a planning perspective, everybody's on the same page. Now we'll get back to the site and look at it and change over time. You can navigate to any spot in this 3D model, in this site corridor. What's it look like now? What did it look like then? Oh, wow, that is great. So you have progress reporting at your own fingertips. And most importantly, everybody on your team has the same capabilities. Now we're going to look at the same in a 2D format. Equally helpful, especially in looking at something of this nature. And you're able to gather any analytics that you please on both of these outputs, both of these models. Okay. Another great use case for a dock, this is going to be a quarry. In this case, we're going to see some representations and some analytics being gathered, stockpile analysis. But it's also important to note that within quarries, the site operator is required to go down and pre-inspect the site in the pit before allowing any personnel there. Imagine being able to come in, your dock has already collected the data, you visualize it immediately on the system, and you're able to ascertain, yep, all is good, we're ready to start work. We're seeing a stockpile report here. We've made those measurements. Now we're seeing the stockpile report, and you can really understand not just the quantities, but the valuations of each one of those individual stockpiles, so you can remain in constant understanding and visibility of what your assets are on the ground. All the materials, the valuation for the densities, all at your fingertips at any time. You can print this out to a PDF and circulate it as you please, and it's part of the documentation. All right, next up, we're going to see another great one. This is slope stability. These things never happen in close quarters, in close areas to where your operators are, so adding a dock to monitor these kinds of situations is critically important. And it really helps you understand not just current condition, but understanding that change over time. Has anything moved? What are we dealing with? And you could look at this in 2D or 3D and make analytic gatherings on any portion of this. But imagine the ability to see this over time to truly understand how that area is performing and what your risks are. Understanding how data is collected, always at your fingertips, and being able to get in depth into any area that needs to be inspected. Within the gNext platform, we utilize AWS, Amazon Web Services, and their security, and we always encrypt end-to-end. We're SOC 2 compliant and Privacy Shield and GDPR as well. So we take your privacy and your data security as seriously as you do, and AWS, our partner, does as well. let's take a look at the walkthrough. So we started at the end with the results. Now we're at the front end where you go in, you create your project, simple series of steps. You add some data defining it. Okay. Next, you're going to select from a drop-down box. Now, we've got drone in the box docs for automated data collection. I want you to consider gNext as your photogrammetrist in the box, because from the drop-down box with this asset type, we have 42 specific asset types where you can define and understand, okay, I'm looking at a dam, then you don't have to get in and play with the switch settings. We've got it covered in that regard, because what we do, each one of these asset types is represented internally by a highly tuned algorithm that passes all the parameters for great processing for that specific asset type. So you're always guaranteed a great outcome the first time around. So where you've got drone in the box, now you've got photogrammetrist in the box. Next is a matter of the data collection. And there are several ways this will take place. You can see down here, we augmented the FlytBase sync right there, and you're able to access the data that's been uploaded. So instead of looking on your local drive or an SD card, you can go right to the uploaded data from FlytBase, and that is your processing. Next, we'll see how that looks. You first are provided an overlay on the right side about how that data was collected and where those images are. This gives you the opportunity to deselect any images that might be strays that are not going to be helpful to the model, and quite frankly, are just a little bit of a bother. They were collected on the way in, whatever the case might be. Also, you can define your ground control points here and really hone in on that accuracy. Next slide, please. Now, it's uploaded and processed automatically. When it's completed, you get an email. The requester gets an email saying, hey, your project is complete. It provides a link where it automatically takes you into that model and that project where you can begin inspecting, but as importantly, inviting others to that specific project so you can collaborate online. Next, please. And now we're looking at the actual site, the actual model. You can see where there are, or the AI has done its work, our Inspect Assist has done its work in defining and helping you understand current condition with loads of details, which we showed at the beginning of this presentation. Next slide, please. And you can always create reports and send those around that give all the information. So those that can't have access online will certainly have access wherever they might be. Next slide, please. And the same was with CAD, the ability to export those defects and all the data around it, including the legend defining what the color-coded items are on that screen, as well as a quantification table that helps you understand the total amount of cracks, the total amount of efflorescence, whatever the defects that were detected in that model. Next slide, please. And sometimes, we can beat our own drum all we want, but, it somehow means a lot more when customers say it. And we've got two great customers in this situation that are helping you understand what they have found. In EXP's case, they had a data set that was very complex and very difficult to work with. They tried it for weeks on end with other platforms. They contacted us. We were able to make a great result. And their response was, hats off to gNext team. That's their quote. And with Stantec, I could not have summed it up better. The best platform in the industry for asset management. We'll take that all day long, but we work hard to earn those accolades for them, and we'll do the same with you. Next slide, please. And that concludes this riveting portion of this presentation. Jinka?
Thank you, Russ. Thanks a lot. And it's really great the amount of tools that are in the gNext platform, using which users can, of course, have a timeline of and the progress monitoring of their projects, as well as they can get down to the nitty-gritties of their assets. And another interesting thing is how AI is changing the inspection process, wherein earlier, after the digital twin is created, the operator or the project manager, they had to manually zoom into specific areas to detect cracks. But with AI into the picture, it's going to save a lot of time for all of these users when they use the gNext platform.
Thanks, Ajinkya. Thanks, Russ, again. Excellent presentation, Russ, and for walking us through the platform once again. So 42 asset types, that's quite a bit, right? And it goes on to showcase the capabilities of the gNext platform. One thing to quickly summarize what we noticed from the polls and previous conversations as well from all our partners and customers is that the inspection processes that they currently have are of a lower frequency, it's of monthly frequency or more. And drones have already started providing so much value in terms of increasing this whole or decreasing the frequency of inspections compared to manual operations. And you already also showcased one slide where the cost value that it brings in. With the introduction of docs, I think there are so many other, like along with one use case, you can cater to multiple use cases at once as well. So in a particular dam site, if there's a security requirement or an inspection requirement or any of the other use cases that you've catered to, there's a construction going on. So it could be used in a multifaceted manner, which will just add so much value. So
Right.
again, thanks for the walkthrough of the platform. And with that, we'll now open the house for Q&A. Anybody from the audience, if you have any questions for us or Ajinkya, please feel free to add them in the Q&A tab. I already have a lot of questions coming in, so I will I'll be taking them. So first question, I think for Ajinkya, is that the docs that we mentioned in the initial slides were DJI based. So is there any effort to work and integrate with Skydio? And even Russ, you can share how it's going on with Skydio as well.
Sure. So FlytBase, we are a drone and hardware agnostic platform. So we are compatible with a range of docking stations, drones that are available in the market. And if you have a requirement where you're using a Skydio dock and would like to integrate with FlytBase, we can certainly do that for you.
Yes, and we are also looking and in touch with Skydio and working on integration for their new upcoming platform. So yes, that's obviously in the books.
Great. And I'll just say that Skydio is a great partner with gNext. We have a cloud integration with them, and I think that they offer capabilities that are unique in the industry. And I'm really excited to hear that FlytBase is working proactively to make that connection as well. I think that'll be a great addition to the ecosystem.
Another question is, I think you've covered that already, but Russ, if you would like to, share again. So you mentioned there were 42 asset types, but I think there's a question around what kind of asset does gNext specialize in? So if you would like to take that.
Absolutely. We specialize in the use cases that our customers find the most challenging and the most relevant. We have 42. We have 3 different bridges as an example, because there are a number of different bridge structure types. We have dams, electric substations, nuclear power, cooling towers, so anything that's in the built world. So buildings, roofs, cell towers, anything that's out there, we either have it or we will. So we didn't dream up all these use cases. They were presented to us by customers over time. And if your specific use case isn't listed in our current arsenal today, the way we get better is by adding those new features, and we welcome that and add to it on a regular basis.
Got it. A follow-up question to that, Russ, is how does gNext handle large amounts of inspection data across the different sites?
We handle it exceptionally well. We haven't found a model that we can't create and model well, so long as data is captured properly. We routinely see 10 and 15,000 image models come through. We've got some that we anticipate in the not so distant future that will approach 25 and 30,000. We're able to throw more and more processing power through it through our Amazon Web Services cloud. So the size of the data collection is something that we embrace, and I will say we are unique in that regard, and we don't have known boundaries to this level. Knock on wood. When we do find it, though, we'll overcome it.
Right. And the Department of Transport example that you showed, the few miles long roadways, that could be one of the key success stories which supports the answer that you just mentioned.
Exactly. We recently processed a dam with 13,000 images, and we're getting ready to do another one that's going to have close to 20,000. So yeah, we're ready and willing, and we embrace it.
Thanks, Russ. So you already mentioned during the presentation while you were showcasing the query use case that gNext does generate automated PDF reports for the identified issues with the volume and stockpile reports as well. So does it also generate issues when it identifies them for other asset infrastructure PDF reports automatically? How does that work? There's a question around that.
Well, the reporting is automatic in the regard that if stockpiles have been annotated and they've been traced, and if AI has been performed, and if manual annotations and measurements have been made, all of that is swept up into the reporting automatically and very concisely. So yeah, that's a hallmark of the platform. You need to be able to look at it visually, but you also need to have reporting that can be shared with others as well. So it's all in there. And as a matter of fact, we're consistently being asked for tweaks and modifications that can really benefit certain class and asset types. And we routinely go through and make those modifications. And it's a cloud-based solution, so any features that we add are available for everyone.
All right. So I have a few questions for Ajinkya as well from the FlytBase side. So one question is, what happens if the network or internet connectivity is poor during live operations?
Sure. So the FlytBase platform already has these few fail-safes in place, which address the issue of what would happen if there's a low network connectivity, and what would happen in case, for example, even the drone loses connection with the RC. So we have these fail-safes in the system already, which the user can pre-configure and set the final actions. For example, let's say there's an internet connection lost for about 30 seconds. The user has the ability to define the action. When there is an internet connection lost for 30 seconds, the drone should automatically trigger return to home or return to docking station. So these fail-safes are already there in the system.
Right. And one question is around, is the entire inspection lifecycle on the FlytBase dashboard, or do people need to keep switching gNext? So how does that whole integration work primarily?
Sure. So FlytBase will primarily focus on automating the data collection part, where all the images, videos will be brought to a single point, and from there these images will be sent to the gNext platform. So the life cycle by default will not completely happen on the FlytBase platform, but if the user has that kind of requirement, those kind of customizations can be built on the FlytBase platform. So by default, data collection, automation of the data collection will happen through FlytBase, and all the post-processing and analytics will happen on the gNext platform.
Right. I think we are getting to the end of the webinar. So before we close the show, Russ, do you have any closing thoughts?
My closing thought would be that you know, the entire industry, the ecosystem around drone collected data and and processing is really maturing at such a rapid rate. It's so exciting to see these new advances that are taking place in both the hardware and in enabling that hardware to do more autonomously. And then on the software side, being able to make actionable insights of that data is really exciting. I think we're at a real tipping point at this time where more and more companies are really understanding the value, and they're embracing the move to the whole digital transformation. Again, we're really excited to be part of this movement, and we're equally excited about our partnership with FlytBase in enabling these incredible advances for infrastructure inspection.
Thanks so much, Russ. So yes, I think definitely we are at a very exciting time, and we are excited to see, how drone autonomy and the entire industry moves to more autonomous operations. With that, for the audience, if there is any questions that you have in terms of understanding more about the gNext platform or the FlytBase platform, we are going to be dropping in the links to the website. So please feel free to go ahead and reach out to the respective teams. Any questions regarding the integration, as well as how this could solve the problems that your asset currently critical infrastructure faces, please feel free to reach out to us, and we will be happy to help you through it. And thanks again for making time today and joining us for this webinar. It was lovely having you, and thank you so much for participating in all the polls. That really gives us an perspective as to what is going on today in the industry. And thanks again. Have a great day, everyone. Ajinkya, would you like to share something?
No, so thanks a lot, Russ, for taking out the time. And like you said, we are really excited for this partnership. And it's really interesting how the technology is advancing. And from the start to the end, all the processes are being automated. And this way, the enterprises and project managers can focus or invest their time on the key aspects of their businesses. So it's really exciting times ahead that are coming.
I totally agree. And Ajinkya, thank you very much. Vasali, thank you very much for your expertise in being able to bring our message out to the wider public. And for all those out in webinar land, keep those cards and letters coming. We'd love to open up a conversation with you and show you how we can all work together to make our critical infrastructure safer.
Thank you, everyone.
Thanks, everyone. Have a great day.
Thanks. Bye-bye.